over 17.
Oh, and you would have gotten the same answer if you did the multiplying the denominator with the, I mean, if you multiply the denominator with the numerators.
I'm not sure what you mean by that. You have to work the
Like,
numerator
if you
separately.
did, would you have gotten the same answer if you did 15 times 7? Oh, I mean, 7 times 17 over 15 times 7.
Yeah, I mean, that's what we did over here. You take the one on the bottom and flip it. I guess I'm not sure what you tried. So like, are you asking about this part right here where the cursor is?
Yeah.
The only way to do this is to multiply by the reciprocal. But because the bottoms are the same, you can just cancel them. It's kind of a shortcut.
Okay.
Is this different than what you've seen in class?
Oh, we mostly do like algebraic ones though.
Okay. I mean, you got to be able to do these. These are not meant to be that difficult. So why don't you try one here, and then we will get some algebraic ones, but at least provide the basis for all that.
Seven over 13.
7 over 13. Okay. So we got 5 over 5 plus 2 over 5, 10 over 5 plus 3 over 5. So that's 7 over 5, 13 over 5. Yes, it's 7 over 13. Good. Okay, so like I said, we're going to move to the algebraic expressions now. And the thing is these are the basic ones again, but they provide the foundation for all the other ones. You have to make a common denominator. So what is the common denominator down here on the bottom? What would that be?
3x.
Yes. Okay. And that's really key. If you can't do that, you're going to be in real trouble here. 9 over 29 over 3x. And then like we've been doing, you take the top or the bottom and you flip it 3x over 29. So it's 27x over 29, like that. All right. So I know this one's a little bit harder because it's a subtraction, but why don't you try this one here for me on your own? Same thing, make a common denominator. This one has a little bit more of a cancellation to it than the other ones, but basically in the same category.
I got 5a cubed over 4a minus 20.
That is correct. Good. Okay. So the other style of problem you'll see, which I was about to do in the numerical one, is where you have it kind of top heavy here. So in the numerator here, the common denominator is 8a squared. So the only real challenge is like if you're not able to figure that out, this becomes a cubed minus 32. All over 4. So this is a cubed minus 32 over 8a squared over 4. So what a lot of students do here is when there's just a single number in the bottom, you don't have to do the whole flip thing. You just multiply by the reciprocal. And what that does there is it gets you to the 32a cubed, 32a squared on the bottom, 8a squared times the 4, and then you got a cubed minus 32 in the top like that. Now, where you run into more problems, more headaches here is when you have to deal with both the top and bottom. And that's kind of the next level of difficulty here.
Mhm.
So let me grab one of those for us to look at. So really, this is it's just like you got to do the top separately from the bottom, bottom separately from the top. It's x squared and x squared as your commons. And on the bottom here, it's 4 over x squared minus x over x squared, like that. This becomes 2 plus x over x squared, 4 minus x over x squared. This becomes 2 plus x over 4
Or
minus
minus.
x. Yeah, and so whenever the bottom is the same, you just cancel those out. And you can actually do the same with the tops, although it's slightly different outcome, but something to think about there. So maybe you try one on your own here.
Can we do one where the denominators aren't the same?
Yeah, well, let's have you try this one and then we'll move to those. These tend to work out nicely by design. Like they don't want to go crazy with them. So I don't know how difficult. That's where it's always better if you send over some problems so I know what you've been doing with the topic, kind of, we kind of have to incrementally work through it. But I'll pull one up here more difficult after this.
- 2x plus 3 over negative 9x plus 4.
Okay. And it might be 4 minus 9x, for a multiple choice, or 3 plus 2x. So good. Great. So yeah, I mean, again, I'm sure you wanted to get to kind of these, but got to make sure that you got it. These are just more of the same though. Like I know that the thought is like, oh, these are so much more hard difficult. It's the same. You just make a common denominator on the bottom and the top if needed. On the bottom here, it's x minus 3 over x minus 3 plus 1 over x minus 3. The top, and sometimes you do this, you have to remember to factor. This is difference of squares, like that. It just becomes kind of a mess. But because of this here, you can actually see a cancellation. You say, okay, that canceled that. What is left over in the top though? What is
No, 1.
there's a 1 there. Good. In the bottom, this becomes x minus 3 plus 1 over x minus 3, 1 over x minus 3. So this is the case where again, the bottoms cancel, but you got to be careful here because it's easy to write the wrong thing. It's still a 1 over x minus 2 because you still have that on the bottom. It's kind of a exam question, I guess. Is this the difficulty, or do you have even more difficult than this? So I know.
It's usually around this kind of difficulty.
Okay, so why don't you try one like it? This text I've chosen seems to have a couple. They always have like two that are like each other. This one's got a lot of the same, not completely the same, but some of the same sort of things to consider here.
I'm stuck on how I'd convert the x squared minus 4.
So it is a difference of squares. It's x minus 2, x plus 2. That will come into play when you mention using the zero factor property. You're gonna have to know how to factor everything. Again, that's like a whole lesson to just do factoring, but you can see down here, you end up getting x minus 2 plus 1 over x minus 2 like that. So this one is a little more complicated. Now, the more you do these, you're gonna realize that the x minus 2's just cancel. But the way to do it properly is to multiply by the reciprocal. So I'm gonna take the bottom here, which becomes x minus 2 on top, x minus 1 on the bottom. That's the flip of this, because the part becomes x minus 1, minus 2. And then cancel, 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 cancel. What is the leftover? What is the result of all this?
1 over x plus 2.
Exactly. Yeah. Don't forget that 1 over. Did you have to solve any of these or just simplify complex fractions?
For these,
Yeah.
we just leave it as like 1 over x plus 2.
Right. So there's solving problems that are like these, but I didn't know if you had any of those. It's okay. It doesn't sound like you do. So here's another one that you might see. Is this something like you might have seen in class?
Yeah.
So this one, all this is you got to rewrite it to start. If it doesn't look like a complex fraction to start, and now it does. So this one is solved the way that we've done all the others. On the bottom here, you make a common denominator, and then you'll multiply by the reciprocal, and you'll see some cancellation. So why don't you give this one a try, please?
Common denominator for the bottom one would be y squared plus x
Yeah,
squared y squared.
squared y squared, yeah.
And the top would also be, well, the numerator for that would also be.
The top is fine. When you have a single fraction, that's fine.
But the
The issue,
numerator on the bottom would be x squared y squared as well.
so you're putting what you're missing. So it becomes just y squared and x squared like that, but they're added together. So the net result of the bottom is, and I'm going to change the order, x squared plus y squared over x squared y
X squared
squared.
y squared.
Yeah.
And then, so the result would be
1 over x like this, and then you have to multiply by the reciprocal.
it would be x squared plus y squared over.
So the bottom always cancels. So this is what you've got to be able to simplify now, the circled part. And it's 1 over x times x squared y squared. The x squared plus y squared is in parentheses. So the x cancels with that. 1x. So you end up getting x y squared on top, x squared plus y squared on the bottom.
Okay.
Oh boy, we really should have you do another, but we are not going to get through. This is the problem. We can't get through everything. So here's another one to look at. I'm going to show you a bit of a shortcut on these, and then we'll move on to a new topic. So when there's only one fraction, you can multiply the top and bottom by the whatever that bottom is to clear it out. Okay, so what you'll see here is that you multiply the x, multiply this x by 1 over x, that makes it 1. X times x gives you x squared. So it's x squared minus 1 and then x on top like that. And you're done. You don't have to do the whole making a common denominator thing.
Okay.
I'll show you
And
one
then that
more.
just
Go ahead.
that'd be the
That
answer. You don't have to
yeah,
simplify
that's
it or
it.
anything.
I mean, you could do different squares in the bottom, but it's the same result. So this one is 1 over a plus 1 over 1 over a minus 1. So again, if you just multiply, because the bottom, if you, it's kind of a shortcut. It works in these. You can say, okay, well, if you multiply by a and everything by a, you end up getting a, sorry, 1 plus a over 1 minus a. You can make the whole common denominator thing, but you don't have to.
Okay. For the one right above it though, why didn't you distribute the x?
I did. It becomes x squared, and then x over x is the one.
Oh yeah. Okay. So
Yeah, it's so short. You're like you can, it's easy to think like, oh, you didn't do anything, but those only work in some examples. Okay,
okay.
like there's no, these don't always work. These are shortcuts. All right, so we really got to move to rationalizing. So the most basic example is something like 6 over the square root of 3. You rationalize by multiplying the top and bottom by the root. This becomes 6 root 3 over, can you tell me what the bottom becomes?
3.
It becomes 3. And then sometimes you have to simplify here. This becomes 2 root 3. But it doesn't always work. Like it could be 7 over root 2, and you multiply the top and bottom by root 2. This becomes 7 root 2 over 2, and that is everything. Now you'll also see problems, sorry for the, you'll also see problems like this, like 16 over the square root of 8. Okay. You are supposed to know to reduce this first. And if you're not sure what I mean by that, please let me know. But do you know what the square root of 8 is, or do you know a way to reduce that?
It'd be 2 root 2.
Right. So this is really 16 over 2 root 2. Your choice if you want to first divide. I think it's always better to divide because the numbers get smaller. Then you rationalize. And you could wait to the end to do it, but that is up to you. It becomes 4 root 2. So let's take this line right here, and let's say you didn't divide first, okay? Now you have to be careful. You only multiply by the root. You don't multiply by 2 root 2. Like while you can, you don't need to. You still only multiply by the root 2. So this becomes on the top 16 root 2. On the bottom, it's 2 times 2, which is 4. And you still get 4 root 2 like that.
Okay.
So problem I like, because I mean, it kind of encompasses all this. Let me throw one at you here, is let's go 8. No, where did it 8? Let's go 20 over the square root of 12. Could you rationalize that for us, please?
And root 3 over 3.
Like this?
Yeah.
Okay. So the bottom is 2 root 3, which is 10 over root 3, which is exactly what this becomes. Good. Okay. Now it's also possible for you to have roots in the numerator. So you could have like 18 square root 3 over square root 6. And you only care about the bottom, so you multiply by the square root of 6. So this becomes 18 root 18 over 6, which is 3 square root of 18, but you have to reduce this. So can you reduce that for us, please?
Nine root 2.
3 root 2. So 18 is 2 and 9, 3 and 3. So it becomes, oh, you're giving me the whole answer. I see. Sorry.
Yeah.
I didn't realize that you were giving me the whole thing. Yes, good.
Oh, okay.
Okay. So you gotta like fully reduce it. And I don't like, it's like, well, it's like factoring. It's like, how do you know when you're done? Well, if you do enough of them, you know when you're done. I know it's not the answer you want, but that is the reality. Okay. So those
Okay.
are kind of the warm-up questions. The next type of problem you will see is something like this one, where the bottom has more than just a root. Okay, so there's this thing called the conjugate. Did you talk about that in class?
Yeah.
So the conjugate, they make a big deal out of this, but the only thing that changes is the operator. Plus goes to minus, minus goes to plus. That's it. So if it were like -3, it would still be -3. It's only the operator that changes. That's it. Now the bottom is always what's called difference of squares. And that's what we were kind of talking about earlier. And the difference of squares, if you have a minus b times a plus b, it always becomes a squared minus b squared. And so the thing is, like when you do enough of these, you notice this pattern, but maybe the first time you don't. You're like, all right, I don't trust it. So you end up foiling. You end up foiling the bottom, and you get 9 plus 3 root 3 minus 3 root 3 minus square root of 9. And you realize, okay, those canceled, and you're like, all right, it's 3 and it's 6 on the bottom. So you end up getting 3 plus square root of 3 over 6. And you might wonder why I didn't distribute. It's because sometimes you get cancellations that you can cancel out easier than when they multiply in. So this ends up being 3 plus square root of 3 over 2. And typically they want you to break it apart. That's for you and your instructor to decide.
Okay.
The bottom always becomes an integer. Always. Always, 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 always. So if you don't get an integer, double check. All right, so let me have you try this one on your own. You need more time to get this down, or do you have it?
What?
Do you have all this down, or do you need me to?
I have
I
it.
don't know. I don't know if you need an example problem, but here's one for you to try like it.
Twelve minus 3 root 5 over 9.
12 minus 3 root 5 over 9. However, you can reduce. So really, you've got to reduce this. So I would give you some partial credit, like because this reduces to 4/3. This reduces to √5/3. Something like that. Okay, so really quickly, just on this conjugate front, because it becomes more critical that you get the conjugate right as we go forward. Let's say it's the square root of 7 plus 4. The conjugate is the square root of 7.
Minus.
So you gotta be careful here. It's gotta be rewritten as 4 plus square root of 7. The conjugate is 4 minus the square root of 7.
Oh, what is the last one simplified to again?
4/3 minus √5/3.
Okay.
So this one's out of order. That's the point. Like you got to put it in order. Okay, now you could maybe get away with doing it the other way. You just got to be careful there. Like this is preferred. I don't know if your instructor is emphasizing that, but that's preferred. Because it's A plus BI or A plus B root C is the kind of the standard way of doing that. Um, All right, so what if it's like √3 plus √2? What do you think the conjugate would be in this case?
√3 minus √2.
Very good. What if it's -3 plus 2√7? What would the conjugate be?
-3 minus 2√7.
Exactly. Okay, so you got it down now. So reason I bring all that up is the next types of problems, they just get more complicated in terms of like, that wasn't the one I wanted. Sorry, this one's really. Okay. So this one, you're going to multiply the top and bottom by √3 minus √2, √3 minus √2. Okay. So this becomes 5 √3 minus 5 √2. Can you tell me what the bottom becomes?
1.
Yes. So there you have it. Can you combine these on the top?
No.
Cannot, but you could, for example, factor out that 5 again. I mean, if it were multiple choice, you might see either of those on there.
Okay.
So a sort of a classic exam problem here is this one. I'd like you to try, because it gives the appearance that both the top and the bottom cancel out or reduce to numbers, but it does not. So that's kind of your hint here. When you multiply by the conjugate on the bottom always becomes a number. The top generally does not.
Try to solve this one too.
Yes, please. Yes, sorry. Yeah, I'd like you to try this one on your own.
Five plus 4 √3 over -2.
Like this.
I mean, sorry, -1.
Okay. So you for sure can't leave it like this. Like, and what I mean by that is like you cannot, you can divide each of these by that.
It'd be -5 minus 4 √3.
Good, very good. Okay. So the other type that you will see is is this where it's the flip. So give this one a try. Again, it
4 minus root 15.
is that what you meant?
Yeah.
Okay. All right. So let me actually I do need to check this one. So you multiplied by square root of 5 minus square root of 3, square root of 5 minus square root of 3. So the top becomes 25 minus square root of 15 minus square root of 15 minus square root of 9. And that is trying to figure out where you got
If
the
it's
4
root
from.
5 times root 5, wouldn't it just be 5?
There it is. Yes, I made the mistake. That's just like, where did she get that number? So yeah, so it's 5 on the top. It's 5 minus 2 root 15 minus 3, which is 2 minus 2 root 15 all over 2.
Oh, sorry, yeah. It should just be minus root 15.
Well, you divide both of them. So it's 2 over 2 minus 2 root 15 over 2.
Yes, it should be minus. Oh, 1 minus root 15.
Yeah. All right, let me look for a few more problems here. So what I'm concerned about is just the simplification here. Actually, I should check this one. They looked right, but I really don't know. It is for sure -1 on the bottom, but it's 2 plus 2 root 3 plus 3. So the difference here, yeah, it should be a 2 here. No, it's root 6. Okay, so we're not foiling these correctly. That's the issue here. Okay, so let's just try one of these one more time. Let's just try like square root of 3 plus 1 times square root of 5. No, we've already done that one. Let's go through this again. Square root of 3 minus square root of 6, square root of 3 plus square root of 6. So when you FOIL this, it's 3. Oh, sorry, this is a bad example. This is a bad example. The foiling isn't going right on these. So let me just work this one out here again for you. Okay, and it's not the one on the bottom. It's always the one on the top. That's the issue. So that's root 4, which is 2, and then it's root 6 plus root 6, and then plus 3 on top. So it becomes 5 plus 2 root 6. Which is -5 minus 2 root 6.
Okay.
Let's just try one more of these, because we do want to quickly get to the other ones. See if I can find, it's just, these are better to come up with problems that are already. These don't have any, okay. Let's try one more. Okay, so why don't we try this one together here, and then we'll work on something different. So because we did not do one like this where there's only numbers in the or it's not both roots in the top. So this one becomes, and this is where the foiling doesn't necessarily help a lot. You get square root of 18 minus square root of 30 minus 2 root 3 minus 2 root 5. So sometimes nothing combines, and on the bottom you get -2. But you are supposed to try to like reduce these, but sometimes they do, sometimes they don't. Square root of 18 does reduce to 3 root 2. Square root of 30 does not. And none of these other ones reduce as well. And then you have to divide each of them by -2. Doesn't work out great, but it's just like -3/2 root 2 plus square root of 30 over 2 plus square root of 3 minus or plus square root of 5, like that.
Okay.
So the other topic on your list here was the zero factor property. This is the easiest to explain, but it also has the most depth of possibilities. So like in principle, we can talk about, like, let's say you have a function like this and it's negative x minus 1 squared, x plus 3 cubed, x minus 4, like that. So the zero factor property says that you set each factor equal to 0. So x is 1, x is -3, and then x is 4. But there's this other thing to consider, which is multiplicity. Did you guys talk about that?
Mhm.
Yes, no, maybe.
Yeah.
Okay. So if it's even, that means it touches. And if it's odd, it crosses. Now, this one is 1, so it crosses. Okay. So sometimes they want kind of this full picture, and then sometimes they even want a graph. Now, this is like the nice example. What they will sometimes do is give you a polynomial that you have to factor,
Mhm.
and that's where it gets really hard because there's a lot to do potentially on that. What kinds of problems are you getting in class?
Um, Usually we get like 6x squared plus something.
So there's like 5 different types of factoring. There's greatest common factor. difference of squares, which we did kind of cover today. Perfect square trinomials, a equals 1, a not equal to 1 grouping. And then there's a lot of others, higher order stuff here. But these are kind of your basic stuff. So the ones you just described is this grouping one. Factoring. Let me see if I can just find. We're running out of time here. Basically a factoring test where we can maybe find some quickly that that are factorable. Yeah.
Could
so
you
here we
send me
go.
some equations too to solve?
The best thing to do is to just go to the internet and I'll drop this one in the chat. I mean, it's just you just search for exactly what you were looking for, factoring, exam, PDF. But here's yeah, it's just something I found. So this is the type of one of the types of factoring. I mean, it's multiple choice here, which I mean now you probably won't get, but that could help you sort of get started on these.
Is it A?
It is a yes. So where I was kind of going is there's also these grouping problems, which if you haven't seen in a while, could be challenging. This one's kind of nice though. You look at the first two terms and you realize you can factor out a 3x squared from both. And then you immediately put that that over here to the right, you fill in what's missing, and then you end up factoring again the part that is the same in both like that.
Mm-hmm.
All right.
I was thinking more like the one we just solved before this, like more difficult questions similar to that.
Yeah, so this is the a not equal to 1. That's these types. There are obviously more difficult ones than that. If you just want to do a quick Google search here, I'll do a real quick on a not 1 worksheet. Problem is some of these aren't super good. I mean, but there's another one in the chat. So, all right, we do have to stop here for today. Go ahead and stop the recording.